Alright, this is the tutorial for Packet Sniffer, specifically Wireshark for Dr. Shin's 585 class. First things first, you're going to need to get into Kali. We're going to go to the Applications drop menu, Sniffing and Spoofing number 9, and at the very bottom, we're going to click on Wireshark. You're going to see this error throughout the video. Every time you see it, just go ahead and close it. The interface we should all be using is Ethernet 0. Go ahead and double click on it. Okay, we're going to minimize Wireshark and we're going to open our Firefox browser. And we are going to go to aavtrain.com. You'll notice this is a unencrypted web page, so it is using the HTTP protocol instead of the HTTPS protocol. We're going to minimize. Okay, Wireshark should be down here on your menu now. Let's go ahead and bring that back up. Okay, so you're going to see we have some traffic going now. So let's go ahead and stop the capture. This is the start the capture button, and this is the reset or restart the capture. So first thing you'll notice, if you didn't catch it before, I am the 215 IP. We're going to have different protocols listed here. So we have DNS, TCP, HTTP, DNS again. So let's go ahead and scroll over, and we're going to look for the DNS request for our AAV. I went way down here. Should be, here we go. Now we could always filter by DNS if we wanted to. This will show you only the DNS protocols that were being used. But once you find this AAV train DNS protocol, we're going to go ahead and right click on it. Come down here to follow. And we're going to go to the UDP stream. Go ahead and close this. Now this is going to show us all the DNS protocol frames that went out that are related to this sequence. So these should all be AAV train. Okay, so we're going to come to this middle section here. You're going to see this frame 86, Ethernet, IP, UDP, DNS. Now this is actually, if you're familiar with the OSI model or the hybrid model that Dr. Shin teaches, this is your data link layer. This is your internet or routing layer. This is your transport layer. And this will be our application layer. So let's go ahead and click on this first one. And if you come down to this bottom box, when we sent the request to go to AAV train, this is our request right here. And it's actually going to the DNS server first so that the web browser knows which IP address to use. So you can look at the encapsulation type if you want. The area I thought was most interesting was that it shows you what protocols are encapsulated in our frame. So we have our Ethernet data link, right? IP again, UDP, and DNS. So let's actually look into those. So this is our data link layer. So as you would suspect, we should have some MAC addresses. Here's our destination. Here's our source. In our IP layer, we have our source IP. This IP is just for our subnet, so it's a hidden IP right now. And if you remember what an IP packet actually looks like, you might recognize some of these areas, right? Total length, flags, RTTL, what type of protocol it's using, our checksum, and there's our source. Let's go ahead and get into the UDP. So first off, you can see we have a dynamic port that's been assigned, and port 53, our destination port, is a TCP UDP port. That makes sense. That's pretty much all that's in here. Okay, and we have our DNS query right now. Later we'll go look at the DNS response. Okay, so our query is, we need to know the IP address for aavtrain.com. Simple enough, right? So if that's our query, then when we come down here, and these should be in order of when the operating system sends the request, when it receives some information, it should be the sequence. So now we've gone down to the last of the DNS in this sequence, and we have a response. So let's see what our response is. So we can see the query again if we really want to. I'm going to go ahead and hide that because we already know. And here's our answer. So we should have an IP address, and there it is. So aavtrain.com IP address, it's right here. So for your first part of the assignment, you're going to want to take a screenshot of our successful DNS request. Okay, so for the next part of the assignment, let's capture a password and a username. Sounds a little bit more fun, right? So once we've stopped the packet capturing, we can restart it simply by clicking the blue fin here. We don't need to save this. So we are recording, or capturing. Let's go back into Firefox. Now the only reason this is going to work right now is because this page is not encrypted. There is no secure layer, there's nothing. This is just plain text. So for your username, go ahead and use your initials so we know everyone's images are original images and not just being passed around. So my initials are EM, and for your password you can do hacker or elite hacker. Whatever you do, don't forget that Dr. Shin will see this when he grades it. So go ahead and click submit. Okay, obviously it didn't work because it's not a real password or username. We're going to go back to Shark. Okay, so right now I have a filter open, and you might have this too. So we're going to click this little X button right here, get rid of that filter. All right, so we have our DNS, our TCP, HTTP. Let's go ahead and filter for HTTP. So we have two frames that we're using the HTTP protocol. And this one here is post. So the post frame is showing that something was actually submitted. So let's go ahead and click on this. All right, so right here, this is a little bit bigger of a frame than we saw last time, right? So we could drill down into the frame again, but I think if you followed along with the last part, there's our sequence number, you'll recognize this is kind of just going down the hybrid or OSI model again. But let's get to the HTML. Here it is. Let's drop that down. And look at this. Username, EM, and that's what this is where it was in the let's see, in the actual frame. All right, username, password. I just did hacker. Submit, submitted. I don't know why it says true next to login, but oh, anyway, there you go. So this will be the second screen capture you're going to take. Make sure you get your initials and the password And we'll start the next segment here in just a second. Okay, so the website we were just using was HTTP. Restart this. So we were able to see all that information. Well, let's go to a familiar HTTPS website. Go to facebook.com. And let's see if we can see that username and password again. I create, there we go, fake username. Don't worry about your username or password this time. It doesn't really matter because we're not going to see it anyway. Let the web page finish sending out all of its information. Okay, obviously it didn't work. I don't have a Facebook anyway, so let's open up Wireshark. Go ahead and stop again. All right, again I have this filter, so you probably will too if you've been following me. Clear the filter, hit the arrow, and let's see all of our protocols this time. TCP, DNS, TLS. So if you remember what our HTTP protocols looked like last time, it didn't look like this. So this protocol that's showing is OCSP, which is the Online Certificate Status Protocol, which is more or less any messages that are communicated with this protocol are encrypted. Now, just because it's encrypted doesn't mean there's no good information here. You could still see my IP. We could see Facebook's IP. Let's see. Can we see our MACs? Yeah, you can still see my MAC address. We can still see most of the information here in the IP. Yep. Okay, and you can see here where we requested a certificate, which I'll talk about in just a second. So to change up our protocols, why don't we look at SSL? So SSL is our secure socket layer, and its job is to essentially establish a secure session. So we filtered by SSL, but actually the protocol now is called TLS. This is version 1.2. Same thing as SSL as far as I know. I might be wrong on that. So if you remember how I said these usually stay in sequence, so it's kind of cool. We can see how the handshake starts. The client is saying hello to the server, right? I'm 215, here's the server. Server is going to say hello back to me. Now I'm going to say hello again to acknowledge our session is started, I believe. And if I'm correct, and this might be something Alex knows, I think this is one of our keys for the certificate. More or less, the server, see how it's over here now, server is going to send us an encrypted key, and if we accept it, we're going to send an encrypted key back. And then new session starts. So we've both sent encrypted keys to each other and public keys to each other. We've exchanged certificates, and we now have a session open. Now let's see, if you scroll down the side on info, let's see if we can actually find the data. Okay, so I don't know what data this is. This could be the password I tried entering, could be the username I tried entering, it could be another of those. But right here, however, or whichever application data you open in this area, you're going to see this encrypted application data. You can see this one is quite a bit longer. So for your screenshot for this part of the project, just go ahead and make sure you get this encrypted application data showing that, at least for right now, we were not able to see any of the data. It's all encrypted. If you look down here, it says payload is encrypted. So there you go. All right, so this is the final part of the project. We're going to be loading a PCAP, and from that PCAP, we're going to see if we can't recover an image. So let's go ahead and exit out of Wireshark. We don't need to save. Get back into Firefox. And we're going to go to the wiki for Wireshark. So it's going to be wiki.wireshark.org, like you see here. Right, we're going to come down right here to where it says sample captures. And let's go to number 18, HTTP. And so these are all sample captures. You'll notice some of the file extensions are .cap, some are .pcap. Let's go to the HTTP with jpegs.cap.gz. Left click on it. Now if you can, hopefully this pops up for everyone, just go ahead and open it with Wireshark. If it forces you to download it, it'll just be right there in the download section. Here's that error again. Alright, so this is a previously captured library of packets, well, frames. So someone else's computer system did this. We are not doing this currently. You'll see that we are not capturing. So for this part of the assignment, get a screen capture that shows this HTTP with jpegs.cap.gz. So that way Dr. Shin knows you were able to upload a PCAP successfully. This is something we might be doing in the future for some other assignments. Okay, now we're going to see if we can't find an image. There's a couple different ways to do this that I've seen. I think the easiest way, and we're going to do this for the assignment, so we're going to go to File, let's drop down to Export Objects. We're going to go to HTTP. So you'll see we have, what, 24 or so packets. We have our content type. So here's our images, JPEGs. We have size. Yeah, so as you expect, our JPEGs should be larger than just, HTML. So what we're going to do is we're going to go to Save All. Go ahead and save it to your desktop on Kali. So desktop. We're going to come over here to this folder icon. We're going to create a folder. Go ahead and call it Assign 3 or Assignment 3. If the assignment number changes in between now and then, just change it accordingly. Okay, so we should have desktop, assign 3, and just click open. Close. Now if we wanted to save this as a PCAP, we just come here to File, Save As. Let's go. Oh yeah, that's right. Root, desktop. You don't have to do this if you don't want to. Oh, There we go. DSD doesn't really matter. Save. We'd be able to exit. Minimize that. And if we just clicked on this PCAP, it should open up again. Okay. Now if we go to this assignment 3 folder, go ahead and open it. Or not. Oh, there it goes. Okay. And this is the screen capture that you'll be taking for this part of the assignment. So you don't need to zoom in on anything. Just get the folder name and that you have, let's see, 1, 2, 3, 4, 5 images. Ooh, dolphins. Cool. All right. And that's it for this assignment. If you want to keep on watching, I can see if we can capture some images from an HTTP site in the wild. Let's see. Let's go to ABC News. For whatever reason, does not use encryption. Just kind of browse around for a second, let some images load, see if you get lucky. Was that Trump? Yeah, there's Trump. Okay, let's go ahead and get out of here. Wireshark. Let's see if we got anything. Well, there's definitely stuff in here. As you saw with the other folder, it doesn't always translate into anything good. Here's a big JPEG, it might be something. Let's go ahead and save all. Do a new folder, let's call it rando. Open. Okay, some files can be saved. Close. Oops. Yep. There's our rando folder. And let's see if we got any images. All right, here we go. Looks like we got cute kids. All right. Oops, nice pair of shoes for somebody. And some semi-trucks. Cool. So because ABC, shame on them, doesn't use encryption yet, at least on their home pages, we are able to snag some of their pictures. So we should have 5 screenshots now, and that should be it. Thanks for watching.